Hello, this is John Baker again with another NX Quick Tip video. Today we're going to talk about how you can use laws, what we call a law, to control a parameter of a model. In this case, I'm going to control the area of a swept surface or swept body. And so I've already got a model created that is a swept body, and I'm going to edit it. And at the moment, what we're looking at here is down here in this section is what they call a scaling method. And at the moment it's set to constant, which means that it's just the same size as the arc or whatever value I type in. In this case it's just 1, which means don't make it any larger than what it is. But down here there's one that we can control the area. And that's a very useful thing to have. So I'm gonna say that this has an area of 10 millimeters. And so there's the swept volume, the swept surface now, with a cross-sectional area of 10 millimeters. Now I can go in and change that. It's currently a constant law, which means that it's the same value the full length. Now I could come in and change it, let's say, to a linear law and say, let's say go to 25 millimeters at the other end. So now it has an area, starts out with 10 millimeters, ends with an area of 25 millimeters, and you can see that it transitions across here. So this is a way of controlling the size of this swept using what we call a linear law. Now I can change it to a cubic, and what a cubic does is it's sort of a blending function. It starts out sort of in a straight direction, and then it ramps up, and then it ends straight direction. This is useful if you're creating something that has to match up with another part next to it that you want to easily transition, and so this is a normal way of doing a transition like that. Now there's the more interesting one, is that you can come down and you can use other curves for reference. You can even write an equation, or in this case I'm going to use an existing law curve. So I'm going to say by law curve. Now I'm going to come in here and turn on, I have a sine curve that I've created, and I'm going to use this sine curve now to control that cross-sectional area. And so I pick the sine curve, and now I get a model that you can see here. It's sort of like a bellows or sort of a corrugated type of shape. And the cross-sectional area as we move along here is being controlled by the height of this sine curve. Now I can go in and edit that by just simply going into the expression system. Here's the expression system and showing the, here's the actual law curve function itself, the expression controlling that. And you can see it's a sine curve. And basically what we have here is I've got some parameters, like the height of the bellows, the increment, in other words the distance between one cycle to the next, the length of the shape, and then using some formulas here, translating that into how it controls the shape. So in the case of the law, there's always a parameter function, which is usually given a value of t, and then I'm controlling the x, y, z points along that curve. Now z is set to 0 because we're just dealing with a 2D curve in the xy plane, but you could have actually provide additional control in the third direction, but we're just going to keep to a 2D curve in this example. And so the x direction, which is along the length of it, is basically the number of periods in it times the increment. In this case we have a half a millimeter. It's 10 millimeters long, so that comes out to it would come out to about 20 periods or 20 loops or cycles in the sine curve. The second key expression here is the y expression, and that controls the height of the shape, the curve, and that's where the sine curve comes in. And basically it's the sine of a number, which is the number of periods times 360 times this law function parameter, and then a couple of other parameters to control the overall size of this. So now you can see how this controls this. Now if I go in and edit this, for example, I might change the length and say that I want it to be 5 millimeters instead of 10, and this would shorten it. Or I could go in and change the increment and say I want to make it 1 millimeter instead of a half a millimeter, and so now we get a less number of cycles, and of course that changes the shape. Now All of this was done as part of this swept function, and there's several other functions inside of NX, such as surface extensions and offsets and so on, that also can use a law function. And you have, again, the similar settings that you saw me do here. Now, how do I get to the law curve? Well, you could obviously just start writing expressions and defining these curves using normal mathematical expressions that are familiar with people for different shapes of curves. But what we've done recently is we've added to our library, we've added what we call reusable objects library. And in the library, let's go to the metric library, there's a set of law curves. So now you can see here different law curves, catenary curves, cubic, cycloidal, ellipse, helix. Even though we have curves for ellipse and helix, these are actually being controlled by mathematical formulas and not hard-coded into NX. We also have hyperbola, involute, and so on. And here's a sine curve, similar to the one that we were just working with. So let's go ahead and take that. I'm going to add a sine curve to here, and we'll locate it at the 0 center. And then let's take a look at that curve. So there's our sine curve that we just created. And again, if I now go into the expression system, you see those same sets of expressions that you saw a moment ago, only this is sort of the basic expressions. I haven't added any additional function, capability to that, different parameters, but you can see it's all set up for that. So if you wanted to go in and start adding parameters for things like the period and the increment and so on, you could now go in and start adding these parameters and be able to use this sine curve for a function similar to what I did a moment ago with the swept surface, or really for any other purpose that you might want to have a mathematical definition of a curve. Anyway, as I mentioned before, this is a capability that's been part of NX for many years, although we just recently added the library of predefined curves, but the ability to create the law curve and to use law curves and other laws in the various functions has been part of NX for some time. Thank you very much.